And all I am is a man. I want the world in my hands. I hate the beach.
Close your eyes for a moment. Imagine a world where time travel is not a fantasy confined to science fiction, but a tangible reality. Picture stepping into a machine, twisting a dial and hurtling through the annals of history. Where would you go? Would you witness the grandeur of ancient civilizations or perhaps meet your heroes from the past? The allure of time travel has captivated humankind for centuries. It's a tantalizing concept, sparking our curiosity and igniting our imaginations. What if we could rewrite history, relive cherished moments, or even catch a glimpse of the future? While the idea might seem like pure fiction, the reality, as we're about to discover, is far more nuanced. Our journey begins by understanding the very fabric of time itself. Our understanding of time underwent a seismic shift in the early 20th century, thanks to a revolutionary theory proposed by a young physicist named Albert Einstein, the theory of relativity. Einstein shattered the Newtonian notion of absolute time, revealing that time is not a universal constant but a relative entity, inextricably linked to space. Imagine space-time as a vast, flexible sheet. Massive objects like planets and stars create curves and depressions in this fabric, much like a bowling ball placed on a trampoline. This curvature is what we experience as gravity. But Einstein's theory went further, demonstrating that gravity doesn't just influence objects in space, it affects time itself. This mind-bending concept means that time flows differently depending on your location and velocity relative to other objects. The closer you are to a massive object or the faster you travel, the slower time moves for you compared to someone farther away or stationary. This phenomenon, known as time dilation, might sound like something straight out of science fiction, but it's a very real consequence of Einstein's theory, and it's been experimentally verified countless times. Astronauts aboard the International Space Station, for instance, experience time dilation due to their high orbital speed. While the effect is minuscule, their clocks run slightly slower than their counterparts on Earth. This principle of time dilation forms the foundation for the possibility of traveling to the future. If we could accelerate a spacecraft to speeds approaching the speed of light, time dilation would become much more pronounced. A year aboard such a ship could be equivalent to decades or even centuries back on Earth. Upon returning, the astronauts would have effectively traveled into the future. So, while we may not have time machines in the traditional sense, traveling to the future is not merely a fantasy but a scientific possibility, grounded in the laws of physics as we understand them. However, the journey back in time, as we'll soon discover, presents a far more complicated and paradoxical puzzle. Section 4. Back to the past. A tangle of paradoxes and possibilities. Traveling to the past, unlike its future counterpart, is a concept riddled with paradoxes and theoretical roadblocks. While Einstein's equations don't explicitly forbid backward time travel, they do present a host of challenges that make it far more difficult to grasp, let alone achieve. One of the most famous of these conundrums is the grandfather paradox. Imagine you travel back in time and accidentally kill your grandfather before your parent is born. This act would seemingly prevent your own existence, creating a logical inconsistency that calls into question the very possibility of altering the past. But the complexities don't end there. Traveling to the past raises profound questions about free will, causality, and the nature of reality itself. If we could alter past events, wouldn't that unravel the very fabric of our existence? The implications are staggering and have fueled countless debates among philosophers and scientists alike. Section 5. Wormholes, cylinders, and quantum quagmires, unraveling the mysteries. Despite these challenges, physicists haven't entirely dismissed the idea of backward time travel. Some theories propose the existence of wormholes, hypothetical tunnels that connect two distant points in space-time. By traversing a wormhole, one could theoretically travel vast distances instantaneously, potentially even leaping back into the past. Another intriguing concept is the Tipler cylinder, a hypothetical rotating cylinder of extremely dense matter. According to some interpretations of general relativity, an object following a precise spiral path around such a cylinder could potentially travel back in time. While these ideas remain highly speculative and are plagued by their own set of theoretical hurdles, They demonstrate the ongoing fascination with unlocking the secrets of time travel and the relentless pursuit of understanding whether our past is truly set in stone. Section 6. The Quantum Realm, a Leap into the Unknown. The enigmatic world of quantum physics, a realm where particles behave in strange and counterintuitive ways, might hold some of the most compelling clues to the mysteries of time travel. One particularly mind-bending concept is quantum entanglement, where two particles become linked, even across vast distances. Measuring the state of one instantly affects the state of the other, regardless of the separation. Some physicists speculate that this instantaneous connection could potentially be exploited for faster-than-light communication, or even time travel. Imagine using entangled particles to send messages to the past or receive information from the future. While these ideas remain firmly in the realm of speculation, the bizarre and often inexplicable nature of quantum mechanics leaves the door open to possibilities that challenge our very understanding of reality. Section 7. Time Travel, a Dance Between Knowledge and Imagination. The quest to understand time travel is a thrilling dance between scientific knowledge and boundless imagination. While we've made remarkable strides in comprehending the malleable nature of time, countless questions remain unanswered. Can we truly alter the past without unraveling the present? Do wormholes exist? And could we harness their power? Will the quantum realm unlock the secrets of time travel? As we stand on the precipice of discovery, the pursuit of time travel reminds us of the awe-inspiring power of the human spirit to explore the unknown. Whether time travel remains a tantalizing dream or becomes a tangible reality, the journey itself will undoubtedly continue to inspire generations to come, pushing the boundaries of knowledge and reminding us that the universe is far stranger and more wondrous than we could ever imagine.